Good morning, students. We have already started our new chapter, that is force and laws of motion. In that, we have already learned about forces, balanced and unbalanced forces. So, today we are going to learn Newton's first law of motion. Motion, till we understand, is a very complicated topic for all scientists and Greek philosophers. So, when Aristotle came forward with a very innovative idea, but their ideas was proved wrong by the famous scientist, that is Galileo. Then Galileo said that Aristotle was wrong when he explained the motion in different way. So they started that Galileo stated that all moving objects maintain their constant velocity when no force acts on them. Based on Galileo's statement, the motion, which is a word which is very technical or very important in that word, new reform has came. So, because of this statement, what we conclude that any moving object keep on moving until and unless any external force is applied on it. So, to prove this statement, Galileo had done one small experiment. In that experiment, Galileo had taken two inclined planes and this two inclined plane is made on frictionless surface, as you can see in the image. So, what is the meaning of the frictionless surface? Well, frictionless surface means the surface on which there is no friction. So, this friction word is discovered by Galileo. And as we have already studied the friction that opposes the motion. So now let us look at the experiment. So what he had done. So in the first image you can see he had taken a marble ball and then roll it on the inclined plane. Then the marble ball is continue in rolling down in the downward direction. So the marble has attained some velocity. Now what Galileo had observed. Now Galileo had observed that marble is also climb on the other inclined plane. And how much height did he attain? So that height and also that position from which the marble rolls down. So that both the heights are equal or same. So he had said that in that inclined plane there is no friction. So in that condition the marble has rolled down and can attain the same height from where the marble has been rolled. Now in the second part, what he had done, in the second inclined plane, they had reduced the elevation. However, the elevation is going on decreasing. They saw that the marble is still attaining the same height from which height they had been rolled. But however, integration is going on decreasing, so the marble will travel the more distance to maintain the height. Then in the last, what he had done, the second elevation was there. They made that inclination is 0. They made that on the level surface. When second elevation is on the level surface, then again they had rolled the marble from the inclined position. So the marble had some velocity. When they fall from the certain heights, so with that velocity, what did the marble do? They started moving and it maintains the constant velocity or travel with forever. So Galileo stated that if there is no external force applied on the marble, so then this marble will continuously move forward forever by it and it will attain that height from where they had been rolled down. So from this postulate or from this experiment, Galileo had proved their concept. Now you can imagine when we walk on the road or running on the road, so there is some unbalanced force which is acting on us. So we call that force a frictional force. So here if we talk about the marble, we had already said that body is frictionless. So what is unbalanced force on them? So we can say it is also zero. But it is not possible in practical life. It thus suggests that an unbalanced or external force is required to change the motion of the marble, but no net force is needed to sustain the uniform motion of the marble. If we talk about in a practical life while walking, running, we needed some unbalanced force and some frictional force, and due to this only our body stops or hold after traveling some distance. So to stop or hold something, there needs some external force or friction force. So the Galileo approach was liked by the most people. So to justify this Galileo approach or to give more importance to this, Sir Isaac Newton has formulated some laws. Here are the Newton's law of motions. Newton's further studied Galileo's idea and further presented three fundamental laws that governs the motion of the object. So these three laws are known as Newton's laws of motion. So here we will first learn or discuss about the Newton's first law. So now let us start with first law of motion. So this law stated that the object will remain at rest or in the state of constant or uniform motion, but it is acted upon by an external applied force. So this statement is very important in today's life. Now suppose to understand this, I will give you an example. If there is a bicycle which is moving with a constant velocity, so that cycle is moving on a frictionless surface. Unless you stop it with some force, they move continue. They do not come into the rest. So it will continue to move in the same direction and with the same speed. So this is called the first law of motion. Here you can see the another example of first law of motion. So you place a tumbler and then you place a cardboard upon them, as you can see in the figure 1, and then place a coin upon them. Now very fast you pull the cardboard, and now when you pulling the cardboard you can see that the coins fall down in the glass, as you can see in the second image. So if you don't pull the cardboard till that the card is in the rest, and suppose if you pull the card, it means that some force is applying by you. So then what happens? The coin which was at rest, now it will fall into the tumbler. So from the rest it will come to the motion. So that is the thing. That is the Newton's first law. Now come to our next topic. That is inertia. To understand inertia, we need to look at Newton's first law of motion again. Here is the first law of motion. So an object at rest stays at rest, an object in motion stays in motion with the same speed and same direction unless acted upon by an unbalanced force. In the simple word, this means that object tends to keep on doing what they are doing. So it is the natural tendency of every object to resist the change in the state of the motion. So suppose if they are at rest, they would prefer staying at rest, and if they are moving at constant velocity, so they would continue to do so. So this tendency of an object is called nothing but inertia. So inertia is the tendency of an object to resist change in its state of motion. Or you can say the inertia of an object is the tendency of the object to remain at rest, or if moving to continue its motion. So you already know what is inertia, and Newton's first law of motion is also called an law of inertia. Now how does the mass affect inertia? Now mass is strongly related to inertia. The effect of inertia on an object is affected by the mass of the object. So the greater the mass, the greater is the effect of inertia. And the mass of an object is the measure of its inertia. So it means if you have big mass, then the effect of inertia will be strong. And if you have less mass, then the effect of inertia will also be less. Now, as we can say that inertia of the body is directly proportional to its mass. So, what is the meaning of this? If the mass is more, you have to put more force to move. If you have less mass, you have to put less force to it. Now, I will explain you this with some examples. So, here are the examples of inertia depends on mass. Suppose, as you can see in the first figure, here the toy car has a small mass. So, it has small inertia and hence it can be moved easily by pushing. And in the second example, you can see there is a toy truck. As we all know, it has a larger mass than to the car. So it has a larger inertia and hence it is a little more difficult to push the toy truck. Now also take us another example that imagine if there is a truck weighing around 1000 kg. If you try to push it with a small finger of your hand, so the force will be negligible and the truck will not move because its inertia is more. Why its inertia is more? Because it is a massive object. So if the mass of your body is more, then your inertia will be more. That means its resistance is also more. So that is why we call the inertia is directly proportional to the mass. Now let us take us another example. As you can see in the image second, there is a ball. Two bodies of masses is kept. One is of 100 kg and another is of 350 kg are moving with some velocity. When a same force is applied on the two bodies to stop the motion, it can be seen that the lighter body comes to rest within a short time, whereas heavier body that takes a little more time to stop the motion. Clearly, heavier or more massive objects offer a larger inertia. Quantitatively, the inertia of an object is measured by its mass. So, its SI unit is kilogram. Thank you.